Hi everyone, welcome to CIKM 2021 30th ACM International Conference on Information and Knowledge Management. My name is Ashwini and I'm working at LinkedIn as Senior Applied Research Engineer. This work is in close collaboration with my colleagues Nagaraj, Venkatesh and Mohit. Today, Mohit and I will present our work on understanding job seeker funnel for search and discovery personalization at LinkedIn. LinkedIn's vision is to create an economic opportunity for every member of global workforce. These opportunities can come in various forms, like members connecting with other professionals to grow the network, or members upskilling themselves by taking up relevant courses and certifications, or members trying to find their dream job. In order to make the economic graph universally explorable and actionable, we have various search and discovery products at LinkedIn. One such product is People You May Know, also called as PYMK. PYMK helps in finding the right professionals in order to grow the network. Similarly, for LinkedIn Learning, we have various search and recommenders that helps in finding the relevant courses and certifications to improve their skills. Also, we have job marketplace that consists of search, recommenders, as well as notifications to assist in the job seeking journey of a member. And finally, we have feed that contains heterogeneous items from various channels based on the member context. In this talk, we will focus on job seeker intent and job marketplace, and we will show how we improve job seeker experience at scale. So let's take an example of a typical job session. Consider a member got an alert for the relevant jobs, and then she followed through some of them through Jimmy Recommender system. In this journey, she also performs search to refine her overall job seeking intent, and then she browses through few of the job description, and finally ends up applying to the jobs she finds most relevant to her. After the application, she waits to hear back from the recruiter. So as we can see, a typical job session, it consists of search, recommendation, and notification channels. We are also interested in understanding the efficiency of these various career sessions. So as we can see from the first plot, that navigation drives most of the sessions at LinkedIn, and navigation consists of notification and recommender system. But when we want to measure the job views and the job applies, navigation does really worse. And to our surprise, search sessions that contains a search query, they are more likely to reach a job view as well as a job apply. But the problem here is that most of the sessions, they do not contain any search query. So that means most of the LinkedIn members, they do not do any job search. Most of the interaction for them is through navigation channels like notification or recommender system. So how do we make members do more search and finally reach to a given job apply? So we have a product called guided query recommendation at LinkedIn. So when you visit the jobs homepage, and so there is a search box where we automatically try to suggest some of the job search queries that might be very interesting based on the previous interaction with job search products. Similarly, we also have similar functionality on a mobile device. I want to talk about how we formulate the personalized query recommendation task, and I will talk about both the training data as well as the training setup. So here, basically, if you remember, like every session, it can contain a job search query, it can contain a job view or a job title. And since a member can have multiple such sessions across different timestamps, we call it a member job activity. So basically, a member job activity is a group of job sessions organized in the ordered timestamp manner. So we collect all of these member job sessions for each and every member, and we split the job sessions into 80-20 ratio. So where 20% is the future of 20% sessions comes from the future of 80%, and 80% context, 80% sessions is the input, or it becomes a context for us. So the task here is to predict the job search queries in the remaining 20% based on the 80% context that we have. And this also closely aligns with the real application, where based on the current member sessions, we want to predict the future job search queries. So, so about the label space, we want to predict both the search queries in the future, as well as we want to also predict the job search titles from the applied jobs. Along with splitting the data in the time and ordered manner, we also make sure that there is no overlap between the training members and the evaluation members. So at the training time, we sample 20 million members, and the evaluation is done on a new data of remain new 2 million member set. So basically now the problem, it boils down to how we model the 80% context. So this is a typical example of a member job search activity where you have two sessions, and every session it has different micro behaviors. So so we have job search, then it has a view, then it has multiple view, followed by finally a click. So, and every micro behavior, it consists of certain metadata. So in case of job search, the job search query is marketing strategy, and then for a job view, at at a company named Impossible Foods, the job title is Director of International Partnerships. So as you can see, this data can be treated as a sequence of tokens, and we choose to pretend, since the data is very different from general Wikipedia or the other natural language. So we choose to retain a BERT model from scratch on this job session data. In case of BERT, we have sentence A followed by sentence B. So in our case, a session is a sentence. So a session followed by another session becomes an input to the BERT model. In terms of the data size, we have total 1.4 billion sessions, and we retain a 12-layer BERT model with 128 hidden dimension and on a custom vocab of 100K subwords. Also, we only train this model on MLM loss, because with NSP loss, we don't see much of performance gain. This whole network is trained in a multi-node, multi-GPU setting on LinkedIn in-house cluster. In terms of the fine-tuning, like we saw in the previous slide, that we want to predict the search queries and the job titles in the applied jobs in the future sessions. So it's a extreme multi-label classification setup, and the input to that, this here is the feature vector from the BERT model, and we have various choice in terms of feature vector. We can select as many layers as you want, and also we can also select the CLS token, or we can choose to take the mean embedding from a particular layer. So I'll talk about the evaluation setup here. So we basically want to measure three metrics. One is the precision at the rate K, that aims to understand out of the suggested query how many queries are actually correct with respect to the member. Then we have semantic similarity. So semantic similarity at the rate K aims to address the issue where the predicted query and the true queries are very similar to each other, but still precision at the rate K considers it as a incorrect suggestion. And the suggestion coverage is the third metric, which basically aims to address the issue of bias in the model. So we want to also make sure that model suggestions are very diverse. They are not only biased to the very frequent labels that the model saw during the training time. So as we can see, CNN BERT, we experimented with CNN BERT and FastText model, and BERT style model, they were consistently outperforming both CNN and FastText. In case of BERT, we have two config. One is the end-to-end fine-tuning of BERT, where the BERT parameters are also getting updated, and one is the feature-based BERT plus slice model, where we take the feature vector from the BERT, and this feature vector is feed as an input to the slice model. And And here we particularly we observed that the slice based model does a much better job in terms of providing much higher suggestion coverage. So we choose to deploy the slice based model in the production, and we found that we could achieve significant job applies as well as a metric named PCH, so which is called predictive confirm hire. One more one Another insight I would like to provide, and we were also interested in finding out if we can capture some sort of member similarity. So let's say a member with a certain heading or certain current job title, we wanted to see if such members are indeed close to each other with that are having. I mean, if the BERT model is able to capture such semantics. So let's say there is a member with title as senior counsel, intellectual property and licensing, and when we computed the session embedding of this member, we were able to find that the nearest members with this particular member are the ones that are having similar job titles like senior corporate counsel or deputy general counsel. So this particular insight helped us to ramp this model into another use case that Mohit will cover about. So I will hand it over to the Mohit for the experimentation part. Thank you.
Thanks, Ashwini. Hello, everyone. I am Mohit, and I am a senior applied research engineer at LinkedIn, and I will be presenting the rest of the slides. So we leverage the insight Ashwini presented in the last slide and use it for jobs notification use case, where as soon as a job is posted, we push out these jobs as a notification to the relevant members. There are some ranking systems which work on exact match candidates. But what we realized was that the recall was very low. So we took this exact match members and we looked at the intent vector for those members, and we expand through a nearest neighbor search that we built through a HNSW index. This index was distributed to 16 charts. The idea is very similar to this job seeker similarity observation, and we are using it for expanding the recall. When we ran this system in production, we saw a huge gain in recall, and job applies went up by 123% in the notification domain, and in the entire ecosystem, applies went up by 0.43%. Moving on, in job search, we have another problem in which we are using this frozen member intent vector, which is computed daily, but we wanted task-specific architecture. It is a typical wide and deep architecture in the learning to rank method for job search. So the wide features typically consist of query, job context, member interaction features. Deep features whereas typically consist of, again, query, job document, context, followed through some transformers-based neural networks. And then these features are concatenated, and again, some neural network architecture is optimized for job engagement purpose. What we did here was that we added a couple of fully connected ReLU layers on the top of these intent vectors, and then we allowed the model to figure out the right weights for these added layers. We saw a lift in NDCG at 25 and also in the AUC ROC score. With this ramp, we also saw an improvement in job applies and PCH metric, which was again a core metric for this product or downstream use case. We also tested this model on another task, which was in the job recommendation setting, where in job recommendation retrieval, we added a bunch of clauses, which were the output of the XML model. So we have some existing production clauses as shown, and then we added some of these XML clauses. And with this addition, we saw uplift in the retrieval accuracy as well as in the EOC score. When we ran this model to production with this personalized clauses, we also saw an uplift in the applies, which was again one of the core metric. So overall, in summary, what we what we have done here is that we unified these member activities across these channels, and then we train some efficient bird style model architectures to summarize these member activities and represent them as embeddings. Then these pre-trained models are fine-tuned for various diverse set of downstream use cases and are used also with this XML problem formulation. These fine-tuned member embeddings are computed daily. So they are daily flows which run to compute this member embeddings, basically inference this member embeddings. And then we store this member embeddings in a key value store, a scalable key value store, which is called Venice at LinkedIn. All the search and discovery channel basically consume these member vectors from this key value store. At a very high level, from the A/B test that we conducted, we observed that for the guided recommendation use case, we saw first order clicks went up. The clicks basically we saw on based on these suggestions we provided, and it also creates a ripple effect in the marketplace. In the job notification use case, the recall went up with neutral dismisses of notification, and it was one of the highly impactful experiment where in the notification system. With the personalized clauses we added in the job recommendation and retrieval use case, we saw that the quality of matches went up by 3.1%, and that's measured based on the user explicit feedback. Overall, we saw that in searches and sessions help to increase the unique applicant metrics overall. From the ML engineering perspective, we saw that we could standardize these embeddings through large language models. These frozen member intent vectors are adapted to various downstream tasks. It's also a departure from previous count statistics like min, max, average of past interacted items. In job search ranking tasks, we observe the impact over these aggregate statistics metrics. In summary, we will conclude the talk by saying that at LinkedIn, search and discovery is part of the daily habits, and there is a huge opportunity in driving the value of members through this deep interest and intent modeling. In the job optimization funnel, we saw that we can apply state-of-the-art NLP models with the XML setting, and we demonstrated application of it in various downstream verticals. In future work, we want to explore cross-vertical intent embeddings. Secondly, many of the sessions are sparse, so we also want to model some sort of graph neural architectures to capture these session properties. Third, we also want to see how we can tap into the structures of the job funnel to capture time and micro behavioral relationship in this funnel. At last, we would like to thank many colleagues from Career CI Engineering Foundations at LinkedIn, and also teams from Microsoft Research. Finally, thanks for your time.